Today we're going to discuss audiograms, break them down, and practice a couple. As you know, there are three distinct types of hearing loss: sensory neural, conductive, and mixed. Each of them have distinct features that are shown on pure tone audiometry, otherwise known as an audiogram. In sensory neural hearing loss, air conduction and bone conduction thresholds are outside of normal limits with no significant air-bone gap. Within conductive hearing loss, bone conduction thresholds are within normal limits, air conduction thresholds are outside of normal limits with a significant air-bone gap, meaning it has a gap of 15 decibels or more. In mixed hearing loss, air conduction and bone conduction thresholds are outside of the normal limits, and there is a significant air-bone gap, which of course is 15 decibels or more. Now, we can describe our audiograms in 5 ways: laterality, symmetry, degree, configuration, and type. There are a couple questions that I use to help me figure out all these 5 descriptors. 1. Do the right and left ear thresholds look similar? 2. Is there significant, as in greater than 15 decibels, of an air-bone gap? 3. What general shape do the thresholds give us? 4. Is there a degree, in decibels, that matches with most of the thresholds? Alright, let's look at a couple of audiograms for practice. Thinking about our questions, let's start with number 1. Do the right and left ear thresholds look similar? Well, at quick glance, you can see that yes, they do. Our air conduction on the right side looks just like the air conduction on the left side. Same thing with the bone conduction all the way up here at the top. So moving on to our second question, is there a significant air-bone gap? Remember, significant meaning anything greater than 15 decibels. So let's start here at our 250 Hertz threshold, air conduction threshold specifically, and count how much of a distance there is in between our air conduction and bone conduction thresholds. So we've got 5, 10, 15, 20, 25, 30, 35, 40 whole decibels of a difference between our bone conduction and air conduction. That definitely has an air-bone gap. Looking at our left air conduction, I'm not going to count it out because clearly the left has a larger gap than the right. And looking at the rest of the audiogram, I can safely assume that there is a significant air-bone gap between all of my thresholds. So moving on to our third question. What general shape do the thresholds give us? Doesn't really look like our thresholds are going quite anywhere. They're kind of hanging out in the same line, give or take, with a little bit of variability on both right and left sides. Doesn't look like it's going up or down or has any kind of sharp dip anywhere. So my gut tells me that it looks pretty flat. So moving on to our fourth question, is there a degree in decibels that matches with most of the threshold? Let's start with the right. The right has thresholds at 40, 45, 40 again, 45 again, and 35, as well as 45. That's going to put us in our moderate area of loss. And just to be sure, we can always do a pure tone average to find out, which is adding up our 250, 500, and 1000 thresholds, and then dividing it by 3 So that's 40, 45, 40 once more, added together and then divided by 3. That's going to be about 43.3 repeating, round that to 43, which is still in our moderate range. Looking at our left ear, let's see, we've got 60, 55, 55, 50, 45, and 45. That borders the moderate to moderately severe area, so I would definitely use my pure tone average to help me decide which area I want to claim this as. Again, for pure tone average, we're going to add our 250, 500, and 1000 air conduction thresholds and then divide it by 3. So that's going to be 60, 55, and 55 divided by, or added together and then divided by 3, which is 53.50 or 53.3 repeating. So rounding that to 53, which places us again in our moderate degree of hearing loss. That finishes our question, so let's reshape what we just found out into what we need to know for audiograms, which again is laterality, symmetry, degree, configuration, and type. Our first question answered laterality and symmetry for us. Since the hearing loss is present in both ears, it's a bilateral loss. And since our thresholds somewhat look similar to each other, which meaning that there's no 10, 15, 20 decibel difference between either of our thresholds in each ear, we can safely say that it's symmetrical. So that's bilateral, symmetrical. Now looking at our second question, our air bone gap question, that's asking about the type of hearing loss. So we said that yes, there is an air bone gap and it is significant. So since we answered yes, there are 2 types of hearing loss that have significant air bone gaps, and that's mixed or conductive hearing loss. So we need to ask a follow-up question, which is, are bone conduction thresholds within normal limits? Looking at the audiogram, yep, that's pretty normal. So since there is a significant air bone gap and bone conduction thresholds are within normal limits, it's a conductive hearing loss, which tells us our type. Our third question, general shape, obviously corresponds to the configuration, flat. And our fourth question, is there a degree that matches with the threshold? That one, as you might have guessed, corresponds with the degree, which we found out to be moderate. So for simplicity's sake, on that audiogram, we've got bilateral as our laterality. It is symmetrical, moderate, flat, and a conductive type hearing loss. To put that in words, it's a bilateral, symmetrical, moderate conductive hearing loss with a flat configuration. Easy, right? Let's try something a little bit harder. Again, let's refer back to the questions. Number 1, do the right and left ear thresholds look similar? At first blush, oh no, they do not. So when we think about laterality and symmetry, it's definitely unilateral, because at first glance I can tell you that this left ear is normal, but this right ear definitely is not. So let's move on to number 2. Is there significant air bone gap? Again, significant meaning greater than 15 decibels. So looking here, we've got our air conduction shown by the circles and bone conduction by our little brackets. This one has 5, 10, 15, 0, 5, 10, 15, 5, 10, 15, 20, 5, 10, 15, 20. So 2 of those thresholds are greater than 15 decibels, but 3 of them are not. So it's safe to assume that there is not a significant air bone gap because of majority rules. So the answer to our second question is no. Moving on to our third question, what general shape do the thresholds give us? By and large, there is no normal hearing is going to be flat because there's no loss. However, for our right ear, in the lower frequencies, it seems to be more poorer than the high frequencies. It looks like it's rising from the low frequencies to the high frequencies. On to number 4. Is there a degree that matches with most of the threshold? Given that it's a rising configuration, not really. So let's take it in steps. Over here in our lower frequencies, it's going to be moderately severe. But in our high frequencies, it's going to be mild. So what is it? Let's fall back to our pure tone average. Through adding up our 250, 500, and 1000 right ear air conduction thresholds, and then dividing it by 5, we get a PTA of 55, which is in the moderate range. Makes sense since it's an average. But how do we say that when describing an audiogram? Just like how we did. Low frequencies have a moderately severe loss, which rise into a mild loss in the higher frequencies. Now let's reshape it into our 5 adjectives to describe an audiogram. We already discerned laterality and symmetry through our first question. It's unilateral, uni meaning 1, and since only one ear has the hearing loss, unilateral only makes sense. 2, asymmetrical, because there's a 15 decibel difference between the ears at 2 or more frequencies. You can find that by looking at your 250 hertz, 500, 1000, 2000, 4000, and 8000 thresholds. Our second question, is there significant air bone gap? We said no. So there's only one type of hearing loss that does not have a significant air bone gap, but bone conduction thresholds, these guys, and air conduction thresholds are outside of normal limits, and that's sensorineural hearing loss. Shape, kind of touched on this earlier, it's rising, so that's our configuration. And degree, we also touched on that earlier. So again, for this last audiogram, our laterality is unilateral, our symmetry is asymmetrical, degree for our right ear is moderately severe, rising to mild, And of course, red for right and blue for left. Blue is normal. Our configuration is rising in the right ear and flat for the left. Although you don't quite need to say that because normal hearing is flat anyways. Our type is sensory neural. So to put that into words, it's a unilateral, asymmetrical, moderately severe sensory neural hearing loss in low frequencies, rising to mild loss in high frequencies within the right ear. Left ear shows no evidence of hearing loss.